would like to thank all of you for coming, and especially, of course, Danny for agreeing to speak with me for a little while about AI, which is a subject that has exploded into the public consciousness in the last year or so. Uh, I am not a professional in the AI field, so I feel like the best thing, the best way to do this is probably for me to just lay my cards on the table first about, about why I'm even here to speak with Danny about this. Uh, while I don't work in AI now, I do have a degree in computer science. And I took my first course in artificial intelligence in 1984 at Johns Hopkins, where I was an undergraduate with Terry Sachnowski, who is now a great godfather of connectionist the neural network approach to artificial intelligence, was an early pioneer. He has gone on to do great things. Well, that was enough to ignite a kind of passionate interest on my part in AI. And I remember, I think in 1985, saying to a member of my family that I'm fairly convinced that within my lifetime we'll have fairly intelligent computers comparable to human intelligence. And that person was shocked. 40 years ago, that was a shocking notion. And the person asked me, the prediction was not completely wrong that I made at that time, but the reasons I made that prediction have turned out to be wrong. I got it right, but for the wrong reasons. Uh, I had thought at the time that uh, with the increasing progress in neuroscience, we will be able to figure out how the brain works, and then we'll be able to replicate uh, that on silicon, and that is how we will eventually create intelligence. Turns out that's not quite how it's gone. Uh, the human brain, we know a little bit about the very higher level functions of the brain. The vision system is fairly well understood, for example. Uh, there are various high level descriptions of the brain that are getting some insights into how the processing is done. We know even more about the very low level, how neurons are connected to each other, how action potentials work, how synapses work, what the neurotransmitters are. There's all kinds of detailed knowledge about this. It's but the mid levels hierarchy of organization of the brain is still not well understood. I would say it's a bit like if somebody knows how to use Microsoft Word and even has some sense of how it does some of the things it does, uh, and also knows that the processor it's running on has some, on the silicon, has some PNP junctions which can be combined to create transistors, and those can be connected together somehow. But the mid levels, for example, the transistors are connected into digital logic gates, which can be combined into things like flip flops, which can hold memories, which can be used to, but no idea about the registers, how the hardware actually, the machine language actually works, how higher languages work, how the operating system works. You just know the Microsoft Word, the very high level stuff, and the lowest level. I see our knowledge of the brain as a little bit like that. the mid-levels are not well understood, and they still aren't well understood. But something shocking happened about a year ago. And it's not, it was shocking to me, certainly. It was shocking to a lot of people. But I have a lot of friends in AI who have been working for decades. I mentioned one, my friend Ali Minai, who is a professor of computer science, cognitive science. He has been working for 30 years on neural networks. He's the president of the International Neural Network Society. He has won millions of dollars in NSF grants to study neural networks. He said to me, when GPT-3 came out, and it became clear to me that it had essentially, by making the neural net, artificial neural net large enough and giving it access to enough data, both of which things hadn't been possible earlier, but now became possible, a relatively simple model. They're not completely trivial. Some people think that artificial neural networks are just a bunch of neurons connected together, and then you put this massive data through them, and they suddenly develop the ability to speak Chinese and English. It's not quite like that. Uh, there is a sophistication to the models and the back propagation algorithm, which powers all this training. It's not trivial. It's not mathematically trivial. It's not extremely advanced either, but you need to know a little bit of calculus and linear algebra and the way these things are structured, and theirs is sophisticated, but it's relatively simpler than what we thought brain, the complexity of the brain is like. So Ali Binai, the same guy, he said to me one day, it's like if in the year 1900, you and I were trying to develop, let's say, a heavier than air flying machine, uh, and there were people saying, no, you'll never do it. And we were trying. And suddenly we found that just some minor modification to a bicycle made it fly. It was so even he was shocked because just simply scaling the with the same architecture, the number of neurons, the number of synapses, connections, which total of which are referred to normally in computer science as the number of parameters. That's one aspect. And then the amount of training data. Luckily, by then, there was enough digitized data in the internet and in the world that they could consume these, and the computing power available became such. The first real jump was maybe around 2012 when Jeff Hinton and his lab in Toronto and his students, Ilya Sutskever and Alex Krzyzewski, three of them, were able to solve some simple problems like handwriting recognition. They mastered it because they had enough computing power then. But GPT-3 really threw everyone, shocked everyone, including at what it could do. Now, my view of this, I might be wrong. There is the reason I'm telling you what I think before I even ask Danny anything is because I just want you to know where I'm coming from and why I find all this so astounding. There have been two approaches to AI: a symbolic AI approach, where you try to build an explicit, for example, if I want to recognize Abdullah, picture of him, and I want to give a neural network a picture of him and have it say that's a good. I can try to measure the distance between his eyes, the exact color of his skin, do all kinds of things like this, perform some calculations on those to determine whether it's new or not. Or I can do this neural network approach, and I will later say how it relates to something Daniel popularized, which is System 1 and System 2 thinking. Uh, it, that way of doing things was proceeding slowly, and I followed how those efforts were going. For example, I was uh, uh, very fascinated by Douglas Leonard's SITE project, which was a massive project to slowly give an artificial intelligence real world knowledge by encoding it in an artificial language which human beings would take one fact about the world at a time and encode it in this language and enter it into a kind of database where you could look these things up. But all of a sudden, when they, in 2012, they found that giving it enough compute, giving it in a large enough number of neurons and synapses between the neurons, and a large enough set of training data through which, with this ingenious algorithm for backpropagation, which I won't get into how that works, but uh, it's really quite something. The way it's an algorithm which you show it a picture and you say, "What is this?" And let's say it's a cat, and it tries to guess, and it says something like it's a frog, and you say, "No, it's a cat." And that algorithm is able to go back and adjust all the synaptic weights in a very large neural network to make it more likely that it will get the correct answer. That's called supervised learning, where everything you present to the AI is labeled. But you don't first show it the label, you let it guess, and then you correct it with the backpropagation. So this became suddenly hugely, and my feeling was in by the time Kevin Roos's article came out in the New York Times in February of this year, where he was just blown away by a chat he had with the Bing chatbot, where it declared it's not for him. Many of you probably read that one. But reading that was a bit eerie, and it really was like talking to a person. It affected me, and I thought I need to look into this. I've been following it from the periphery for a while, and so since then I've been teaching myself the details and the mathematics of the backpropagation algorithm, a lot of these things, and I am convinced that these are baby systems, infant systems at the moment. We have another big step forward was the transformer architecture, which was invented in 2017, and that has made possible these large language models like ChatGPT and so on. But they are doing something astounding. How is it that without knowing how the mid levels of our brain are processing language or this or that, just by putting a bunch of artificial neurons together and adjusting the weights between them using the backpropagation algorithm, that they have suddenly mastered human language. I speak to ChatGPT in Urdu now, and it speaks to me perfect Urdu. Okay, once in a while it sounds like a Pathan. The gender is wrong. But that's because there isn't a lot of digitized Urdu data for it to be trained on. English, it speaks totally perfectly. So I think something extremely remarkable has occurred in the last year. That's my view. There are a lot of people who poo-poo this as no big deal. It's just pattern matching. It's just predicting the next word. It's a stochastic parent is a derogatory term in this. It's not easy to predict. Maybe we don't understand how we are doing what we're doing. Maybe we are sometimes, words are pouring out of my mouth right now. Uh, I'm not quite sure how the next word is being predicted. Maybe it's something similar. Is it a coincidence that you put something that looked like neurons together and put enough of them together and train them with enough data and they master human language? I don't think so. I think something very remarkable has occurred. I think these are very early times in the development of these things. The people who are calling them, think about predict just this criticism that it's just predicting the next word. Well, in a very strict, in some bizarre sense, yes, you can say that's true. They do predict a token at a time, these LLMs. But think of this example. You're reading a mystery novel. You come to the scene where, let's say, Agatha Christie's Hercule Poirot collects everybody in the room, and you're about to find out who did the murder or whatever. And he says, he gives a little speech, and then he says, and the murder is. Now predict the next word. It's not that easy unless you understood the motivations of the various characters in the story that came before. If you've understood what is actually going on, I think predicting the next, this is an extreme example I'm giving, where predicting the next word clearly implies a deep understanding if you are able to do it correctly. And a lot of people who can do that, like my wife, Mark, she always guesses the correct murderer. But, but I I refuse to accept that somebody who is doing this doesn't understand anything about what went before. There is some understanding. There is something going on there that's remarkable. And even if you think about it as predicting the next word. And I don't think that's a good description. So, and I think that these are just the transformer architecture has been there for 6 years now. That's not a long time. There will be new architectures. These things have abilities which we don't have. They are unconstrained by the evolutionary constraints of our bodies. Our brains have to fit into our skulls. Our computers don't have to fit into anything. You can make them as large as you want. They can we communicate with each other with a very inefficient method of language, as I'm doing now. These things can communicate hundreds of thousands of parameters in an instant to the next about something that they have learned. You can clone them exactly very easily. These are all immense advantages. So now I'm not any kind of let me stop there. And now just Danny, could you react to what I've said? Please feel free to disagree completely and say everything you've said is wrong.